I love Guardians of the Galaxy, but I'm also an astronomy student, so I will be critiquing its science fails, which I'm not surprised about because it's Marvel. No spoilers for the new movie, light spoilers for the holiday special, and a lot of spoilers for the first two movies, but who cares because they were out 6 and 9 years ago, respectively. Okay, so number 1, going to Earth, willy-nilly. I said willy-nilly. Okay, James Gunn, the director, confirmed that the movies were set in the Andromeda Galaxy, which is cool by itself, except when you factor in the fact that the Guardians or Ravagers just go to Earth when they feel like it. For context, the Andromeda Galaxy is 2.5 million light years from the Milky Way galaxy. But now you must be saying, oh, but they can do jumps and do wormholes, which is another can of beans itself. And they can travel all the way across the Andromeda Galaxy. Yeah, the thing is, the Andromeda Galaxy is only around 160,000 light years plus or minus uncertainty, which is in the 10k to 100k range. It's a big uncertainty. And Yondu said himself that is not good for mammals to do more than 50 jumps at a time, which seems like a wormhole between a star or two. And it's possible to survive after 700 as seen in the movie, but it's definitely not good for you. So it would take a lot of time to travel between anywhere in the Andromeda Galaxy to Earth, even with jumps. And now you might be saying, oh, but the Ravagers just go pick Peter up in the beginning of Guardians of the Galaxy 1, and Mantis and Drax go to Earth really easily in the holiday special. They both are round trips, by the way, and the journey didn't affect them at all. You can see my problem with the science in that. And so, as I was researching for this video, I was watching Guardians of the Galaxy 1. Drax says in Guardians of the Galaxy 1 that they traveled halfway across the quadrant. So, that gives us a starting point for us to do some math here. So, some assumptions is that the Andromeda is
160,000 light years wide, and it took 4 days to travel halfway across the quadrant, because it's a median from 1 day to 7 days, and days are Earth days and time isn't relative because Marvel's boring. Okay, and something that aren't accounted for is wormholes and jumps effect on time perception. So let's do some math. This is Andromeda Galaxy, this is our quadrant here. So from our quadrant, because this is 160,000, this is 80k, and this is also 80k, it's a right triangle, and we're trying to find, so we're assuming that the halfway mark is right here, right? So we're trying to find this is length. So to do that, we're going to find this smaller circle circumference. So the smaller circumference is going to be 40k, the radius of the smaller circle is going to be 40k, which means that its diameter is 80k. So 8,000 pi is our circumference, and that divided by 8 is, because if you split up this thing by 4 smaller quadrants right there, and it's half of a quadrant. So remember 8 per 1,000, 10,000 pi, which is around 31 and 400 light years. So halfway across the quadrant is now 31,400 light years. So if it took 4 days to travel to that equals 7,850 light years per 1 day. Then since this is an average, a guesstimate that we don't really know, this number could be wholly different, plus or minus 3,000 years, give or take. So we have this speed, and the Milky Way galaxy and the Andromeda galaxy are 2.5 million light years across from each other. So if we do 7,850 over 1 day equals 5 million over X days. So basically we do
around 318.47 days. So it takes a ship like Milano less than a year to travel the distance between the Milky Way galaxy and the Andromeda galaxy. Boom! So they can technically travel to the Milky Way in not 2.5 million years, because they travel faster than the speed of light a lot, but it would take around a year, a little less, around the Earth year. That's a lot of time. So I guess the Ravagers could do it because they're being paid a lot, and they could technically have time for when they should pick it up, because Ego was a butthole who gave his girlfriend / wife maybe cancer. But anyway, yeah, you can see how I have a problem with that. Number 2 is this scene.
Whoa. How on earth do you get reception up here?
A couple of good satellite dishes out front will get you anything within about 400 million light years.
Hi, honey.
Okay, so Earth phones work with electromagnetic waves being sent. And electromagnetic waves travel through space at the speed of light because they are light waves, which isn't much if you're millions of light years away from Earth, like I just said. So I guess an explanation for it could be that it has like an extremely specific path that it goes through to like multiple jump points, but like the jump points seem pretty fixed, so I don't know how about that. And like they're not, light waves aren't mammals, so they can just go through like a ton. So, but that's a really far-fetched explanation, so it doesn't really sound plausible. A smaller scaled example is that the transmission from Mars from Earth takes on average 5 to 20 minutes, and Mars is 140 million miles away on average, which is like way less than 1 light year, and the Andromeda Galaxy is 2.5 million light years. This doesn't make sense. And Kraglin, it's not about satellite dishes. Alright, so, number 3. Xander being a habitable planet. So, take a look at Xander here. Oh, there's a sun. There's another sun. And there's a planet. Like, right up in the sun's personal space. I don't think I need to explain, but since I'm making this video for an academic final project, I unfortunately do have to say why a planet that looks like it's less than 0.5 astronomical units away from 3 suns being habitable and relatively cold is scientifically inaccurate. For your information, astronomical units is the distance from Earth to our sun. So, Xander's surface is very Earth-like with plenty of greenery and really big bodies of water. And from what we see of it, there's probably more water on Xander than on Earth. And it's orbiting 3 suns. To be fair, 2 of them look like they're Class G, which is what our sun is. Which isn't like too big. And there's like 1 M star pretty far away. So at least it isn't orbiting 3 Class O stars, which are really big stars that are blue and very hot. And the dumbest part about this isn't the fact that it kind of is ridiculous that a planet there is habitable. It's the fact that they're not using the 3 stars as their main source of energy. Their main source of energy is something called like megastorms, according to the wiki. Why would you use your weather when you have 3 suns right there? What are they doing? Complaint number 4. Scientific inaccuracy number 4. Hearing stuff in space. In space, you can't hear things without the help of, like, communicators and spacesuits because sound waves travel through your ears by vibrating things like water and air molecules, and there isn't much of that in just the empty void vastness of space. So here are some examples where you wouldn't hear the things that were being heard. You wouldn't hear that. You wouldn't hear that. This is actually a whole chase scene that's like 10 minutes long, and there's a lot of sounds that you would not hear. You wouldn't hear that.
How can I try to explain?
You wouldn't hear that. So, those were just a few examples. There's a lot more, but if I were to show all the examples, then this video would be way over break time. There's so much more scientific accuracies I want to talk about in the future, so maybe I can make a part 2. But in the end, I will give Guardians of the Galaxy 2.5 stars for its scientific accuracy because it is science fiction, so it has some leeway. But, they could have tried harder and hired scientists and listened to them. The bigger problem in Guardians of the Galaxy is the stuff they don't mention anyway. Like, the diversity of alien species, like, they're all humanoid. They never talk about air pressure stuff. They never play around with gravity, the relativeness of time, etc., etc. But after all that, I still love Guardians of the Galaxy, and it's really awesome. Thank you.